Hey, what's up, everybody? It's me, Aaron,
I'm Dell.
and we totally have not been away for like a year and a half. We're rolling right back into it, and we're rolling right back into it because in one of the first episodes, we had thrown on to the end of it a challenge, and somebody finally came up and found out what that challenge was. And so, with us today is also Ryan. Ryan is working reverse engineering right now in the defense contractor space, been in the embedded world for about 7 years, and overall working with poking and prodding operating systems and doing splitty stuff for about 13 years. So, congratulations on being the first person to solve the solution there, Ryan, and welcome.
Thank you. Great to be here.
So, jumping into things a little bit beyond that, just kind of brief intro there, tell us a little bit about what kind of maybe interest you or entice you to come into the wonderful world of hacking.
Well, there's two stories I could probably tell here. Um, the first one is like the classic, hacking video games to try to get more money or things that didn't have cheat codes at the time. Like I forget what that one in-memory editor was that everybody used.
Game Genie?
Oh, I know what you're talking about. Well, that was for
It sounds
consoles.
right.
Game
No,
Genie
no,
and
yeah.
Game Shark.
Yeah, that was for consoles. I did use those. That was fun, but
Was it just
no, I
called
forget.
Memory Hacker or something?
That sounds right. I think I used it for the OG Baldur's Gate
Nice.
to change my character stats. Looking at forums in there, I found out about the world of game trainers and started trying to figure out how to make my own for games. Did I ever tell you guys that I got expelled from high school?
I don't
Or
think
the
I've heard
first high
this
school I
story,
went to?
man. I'm eager to hear it though.
Same.
Yeah, so um, I went to high school freshman year. It was not a public school. I didn't really fit in, and long story short, I may or may not have put a keylogger on an admin system, got a domain admin password, and changed a bunch of grades for myself and for others. Um, and what got me caught actually was my math teacher remembered the decimal point of the grade he gave me the previous semester, and I changed it from like a 94.6 to like a 94.89, and he had like an eidetic memory for numbers, and that's what got me caught. But then they
Wait a minute.
expelled me because I didn't rat everybody out.
You were changing your grade from a 94 to a slightly better 94?
Yeah, I mean, I was trying to make friends. Like the people I helped, like they actually needed the grades, and I
Then
thought
why
it would
did you
be
change
fun
yours?
just to see that I could.
Unfortunate circumstance, but to be the math teachers though that you changed, and they happen to have an excellent recall.
Yeah.
So
I
what?
remember it was like fun just poking around the system. It was strange to me that I could access the like grade management system from a library computer just by having domain admin. Like I had access to everything. Um,
Do you remember the particular keylogger it was that you used?
no, and to be honest, I don't even remember how I found it, but I do remember that it was a PS2 to USB keylogger.
Oh man,
And
that
that the
that's
way that you interfaced with it was like through a text document. Like you would just send it a magic key code, like it would detect a certain string entry on the keyboard and then just dump out its log just like a rubber ducky would.
man. I remember a
Sense.
lot of those transition like technologies and hardwares that came out, like the PS2 to USB, especially recently here. Just been poking around with developing HID side drivers for like USB on the STM32. And some of it, depending on what it is you're trying to interface, takes you back like 20 plus years if you want to interface with like certain devices and things like that to the very like early history of it. And along the way, of course, you come across things like the transition technologies that existed. It's almost hard to remember a time though, like where we didn't have USB. You know what I mean?
So, if I remember correctly, when I've looked into it, wasn't that like just a special mode that the chip had to support? Like it wasn't really USB to PS2 anymore. It was just PS2, but it had a USB connector on it. Was how a lot of the original keyboards kind of implemented that adapter. And then when you put that adapter on it, it knew either because the lines weren't pulled up or whatever it was.
Yeah, that's exactly, I think, what it ended up being. It was more of a literal physical translation type situation that ended up kicking around versus something that you had to spend a lot of laborious time like programming around, because it just like most of the standards too when they first came out, right? They're still, look at any two different things and you have wildly different implementations. Oh, even today that's the same. The same is true with like TCP/IP stacks on different things, right? Like it's not necessarily, anybody who's spent any time on Wireshark knows that no two stacks necessarily are alike depending on who the OS people for responsible for creating that driver were. But I digress.
Oh, definitely. Do you remember the early days of Bluetooth when like everything was just trash all of the time? No two Bluetooth devices could talk to each other practically.
That's right, and they didn't have the authentication pen mechanism even conceived of, I think, at the start. So you couldn't even pair through that button system that came shortly behind it. It was just someone could connect to your stuff, and good luck.
Oh yeah. Or if they did, it was like all zeros or something, right? Because you'd have a device that just had it implemented as a default, and like you couldn't change it.
Oh yeah, they were hard coded like 0 pins. Yeah,
Yep.
You
I
still see
Those were
that
the
pretty
days.
often.
You do. It's sad. It's not good.
I
It's
don't know
not
if you
good at
guys
all.
have taken a look at the work. Have you messed around with any of Travis Goodspeed's devices? Or I believe that him and a lot of the other usual suspects in the hardware hacking space, to include like Kate Timken and people, have created like the Face Dancer and some of those devices to kind of hack around on Bluetooth. Have either of you experienced playing around with that yet?
I have not.
I haven't either, though I do have something for that. It's like a blue something. It's like a Bluetooth hacking tool. You plug it into USB, it's got the radio on it and everything. I just haven't had a chance to play with it.
I actually think I might have. I had a Bluetooth sniffing tool. Yeah, actually, I have it right here. Bluefruit LE friend. I was using it to debug some forward engineering work I was doing for a company when I thought I might want to switch from reverse to forward engineering. It was only like $25. It's a Max 32625 Pico. Or is
I'll,
that just a different case?
I'll have to throw some of that
Nope.
there in the show notes for some of the stuff that I was talking about previously, as well as that model, and have other people take a look too. And what you just mentioned there, when I was thinking about doing, switching from reverse to forward, I think is a good segue into kind of the next question too. Like, what was that the idea back then when you kind of got the thrill of being on there and having domain admin, that you wanted to get into like reverse engineering for like your primary way that you make your living?
Yes and no, right? So I didn't like getting in trouble, um, and the fallout and the consequences from that. So I kind of stayed away from that world for a while, and then just went the like more traditional computer science route in college, and then through graduating college and doing some of my master's work, realized there was a way to get back into sort of mysterious allure of the hacking world legitimately and stay on the socially positive side of the spectrum, if you will. When I got back into it was after college and grad school, and then found out you could get paid for it. So that was nice. So I don't know if I've still decided this is what I want to do for a living, but it's fun and I can get paid for it.
There was a great episode, I think, of another podcast that I was listening to not long ago that talked about the intersectionality between creative types and, enjoying kind of the act of, creating stuff. So to the point you were just making about, I thought I would spend some time doing some forward, and now I find myself back on the reverse side of things. I know there's a couple of people curating some older malware, like ones that, date back to the bulletin board system days. Do you find that you kind of have that similar spirit too of oscillating pretty often between creation and like then pulling apart stuff to see how it works?
Yeah, a little bit. I think I get a little bit stir crazy if I spend too many days in a row looking at a Geedra database. Wanting to shake the dust off of, my Python or my C skills. But for like, no kidding, professional forward development, that requires a whole set of just discipline, I guess,
Yeah.
that I just don't have the span to develop.
You're saying sticking with something in multiple teaming and like, oh, I've got this small piece, but I just want to move forward, but I've got to wait for this other person to finish their piece. That kind of like
Yeah,
just steady state.
that or implementing, a huge like SAE standard. I worked for a company doing embedded firmware development for like electric vehicle charging hardware. So like implementing a protocol that's defined in this 1,000-page document, and you're just writing the library for it, it just gets pretty monotonous pretty quickly. But then like the little puzzles that you run into as you're doing development with hardware is a lot more enjoyable than with just pure software, because one, there's more toys to play with, I guess you could say, and more, physical manifestations of the code that you're writing, hopefully not blowing things up, which was a real risk when you're doing like developing a high capacity electric vehicle charger.
Yeah, no doubt, no doubt. When you talk about that too, I'm curious from your perspective, in terms of the tooling that you're typically using. It's been my experience that when you're dealing with things like malware that comes off of a commodity operating system, you can take for granted pretty easily how much tooling has existed or exists out there, and kind of how many shoulders you're standing on. With the
Oh,
embedded world,
100%.
I find it to be way different. Could you tell us a little bit about like what your workflow kind of like maybe in the forward versus reverse looks like, and maybe some of the common tools you like and love, especially for the embedded side, which seems to have much more of like a dearth of them than the commodity operating system side?
Yeah, and I think a big part of that is just the variety of chipsets you have out there, and there's no like
Yeah.
been some attempts at like a unified development, framework. If you live in the ESP32 world, a little bit of that, just because they have quite a few different chipsets, but they've been around long enough to like build up this ecosystem of different tooling. And you can even get their like development environment integrated into like VS Code. But I mean, almost the hardest part of any new project for forward developing on a new chipset is like getting your build chain set up. In a lot of ways, that's true for reversing as well. I mean, once you're at the point where you have a new binary to look at for an embedded thing, I mean, it really depends on the project. But for example, right now, I'm looking at a custom real-time operating system that runs on a PowerPC chip. And I never looked at PowerPC before, and it's been fun, I guess. So like step one was just learning. Well, step zero is make sure you have enough monitors, because you need to have all of the data sheets up while you're like looking at a new instruction set. So one was just trying to wrap my head around the basics of PowerPC assembly, and like trying to figure out why on earth someone would invent some of these instructions. Now, there's an old post, a bunch of posts on Twitter about absurd PowerPC instructions. I'm gonna have to find it. But you'll have an instruction where it's like rotate left with an immediate and mask. It'll take 5 arguments, 2 of which are registers, and 3 are going to be the immediates that you like. You're familiar with the barrel shifter, and I think is it arm thumb mode,
It is arm
or
thumb
is it
mode.
just R?
Yeah, I am familiar.
Yep.
Yep.
So it's one instruction that will rotate, a 32-bit word in your source register, take a specific number of bits from that register and it with your your first argument, and then put the result in that register. And just trying to, first of all, the Geeter decomp does not get these at all very well. Um, and even ChatGPT, I was like, suppose your R2 is this and R3 is this. What's going to be the value in R3 after this instruction executes on PowerPC? And ChatGPT didn't know what to do with that, or it gave me an answer, but it was just wrong.
Confidently
So
Out of
wrong.
yeah,
curiosity, how does the new Ghidra emulation that's available do
I
with it?
have not tried it. I'm still on Geeter 10.4 on our
Oh, okay.
work setup.
Wait, didn't that start in 10.3?
Uh, well, then I haven't tried it.
Okay.
I
Oh
will
yeah,
have to check
new
that
tool
out.
in 10.3. So you might have it. It doesn't execute the assembly. I think it brings it over to P code and then executes the P code.
Oh, I've tried looking at the P code for some of these operations, and it's even more awful. But if I can emulate it, that would be great. Fortunately, I'm at the point where I actually have a debugger set up on this processor, so I can do a
Oh,
lot of
nice.
this more dynamically.
We've talked in
But
the
then eventually,
past
like,
about the show about like dynamic. The quickest route to dynamic is usually the path that you want to take on the embedded world side.
yeah, I 100% agree with that, particularly in this case where figuring out the hardware was sort of only the first layer of problems once we realized this was an RTOS, and Now we have to figure out how this operating system does memory management, how it does process context switching, how it does virtual address translation. My God, this this particular processor. I'm going into the stories of this like kind of squirreling here about the
Yeah, please do.
specific challenges I'm
We love
facing.
squirrels on this
But
show.
so this processor, it's an MPC 8270, which is I think originally made by Motorola, then bought by MetroWorks or Freescale, now owned by NXP.
That's a
So you
classic
already
fact.
have,
Dude,
yeah,
yeah, yes.
you've already got like decades old documents that have been rebranded, and this
You see the
processor.
watermark on all of them.
Yep.
Like on top of each other,
Uh-huh.
practically.
Yep. And so you've got an old processor, and it wasn't out long enough, I think, for there to be a whole lot of development. You know how you can go on any STM32 forum or just like Google any problem you're having with the part number, and someone out there has figured out like, oh, you just need to set this register before you
100%.
set this other register, and that's why
Yep.
you're having that problem. Yeah, none of that exists. None of that exists for this processor.
So let me
Like
ask
there's a
you this.
couple of bulletin board posts.
Is
Go
it
ahead.
that it's a scheduler that they've just like a bare bones scheduler that they then had to roll everything else on their own for? Like, is it tied to? Can you tie the scheduler back to any other project, or is even the scheduler custom?
It's all custom.
Nice.
And what's the most annoying thing that I've been banging my head at for the past 2 weeks is so this processor actually has built-in hardware mechanisms to do virtual address translation. First of all, there's like 1,000 registers on this processor, but there are, a whole set of registers specifically dedicated to accelerating the operations of the memory controller. And there's two memory controllers. There's one for for data, and there's one for instructions. um, you dive into this processor manual, and you try to wrap your head around this like pretty convoluted way of how address translation is supposed to work on this processor based on the way the designers of the processor intended it to be. And so, like, once you are able to back all that out, you go back to Ghidra and realize, okay, none of that is happening. What the heck is going on here? And it turns out they have their own mechanism to do virtual address translations, and they're just using the bare minimum of what's available in the hardware to basically turn control over to their own custom like page table searching and,
Why?
and lookups. So the only thing I can think of why they would have done it this way is because this is a multi platform OS, and whatever engineer was tasked with porting it to this particular processor was just like, okay, what do I need? What's the bare minimum I need to do to get our existing code to work on this thing?
So it wasn't
Um,
a build your own bird feeder type situation, which we talked about in some
Dude,
previous
it may
episodes.
have been like I'm not gonna lie, like it would not have been fun because there's no sample code out there that I could find to do virtual address translation. Like there's some like helpful pointers in the manual, but it's not like you can go look at an example in the Code Warrior IDE to help you do memory translation. So it very well could have been like, wow, this is pretty cool, but this is a lot. This is a lot. So I'm just gonna do virtual address translation the way I know how. So it could have been.
Yeah, it almost sounds kind of the way you described it. Like they had that existing code base, and like every time they bring on a new CPU, somebody just writes modules that get
Yeah,
preprocessed and
or a
directed in
board
to,
support package.
Yeah.
yeah, to just abstract it away so that the code runs the same. Although I can't imagine it's efficient, right? Like I have to suspect that it probably runs a little crappier because of that.
Yeah,
They just deal
definitely.
with it. Yeah, this is close enough. It's fine.
Yeah, I mean,
Custom
it's not
hardware to do
like
this?
it's a
Absolutely not. Forget the silicon altogether.
yeah,
And
but
you know
man,
some engineer
that's
doesn't get to make that decision, right? Like some fucking bean counter or some CEO or something is like, oh, I've got a buddy that works over at this place. He said these chips are great for what we're doing, and then some engineer's got to deal with it.
yep. So there's nothing like throwing out 2.5 weeks of work and going back to square one.
Yeah, so
Man,
I think not maybe necessarily as much in this episode, but probably leading to the next one, we'll probably be starting to lead into a little bit more talking about RTOS in general and doing some RE with them. I can definitely say from my experience, QNX, free RTOS are the usual scumbags that I run into. I think that there was a survey or something like that that was done by Eclipse Foundation or somebody saying that the free RTOS, I think, maybe has a lion's share outside of Linux, just people straight up doing, BusyBox, followed by like No OS or Bare Metal, which is where I think you find yourself at right now for the most part. And then there's some other small ones that we took a look at too, or we were talking about, myself and Dell. QNX being one that was on a lot of automotive systems and things like that, which then now I think has been bought up or purchased by somebody else. We also talked about something that I don't know if you've run into, but we certainly have, QNX, and how absolutely impossible it is to find any kind of example code, how locked down, airtight they are for any kind of documentation that's outside of their like paid platform. You just can't find anything.
Did you mean VxWorks?
Or VxWorks, yeah, not QNX, VxWorks. Have you run into them before on any of your travels there? And have you experienced something similar?
I have not worked on VxWorks stuff specifically, but the situation you described where the development ecosystem is totally locked down is 100% where I'm at with this project. I don't have a good solution to that because I pitched the idea to my team of going to the company and saying, okay, we're developing something. We'd like to use your RTOS. Please give us your SDK. But then the NDAs come out, and if I have to sign something that says I won't reverse engineer it, then I'm, yeah.
violating the NDA. I gotcha.
Yeah.
What a catch-22.
How do you get into those spaces where that's acceptable?
Yeah.
But Dell, I think you
Currently not operating in that mode.
Dell, had you mentioned some others too that you had run across and some stuff that you had messed with before?
So I have run across VxWorks before. Most of my VxWorks experience outside of work was old routers, right? They switched to that on the old DD WRT 54Gs back in the day. That was, I think, the second or third generation of kernel that they used on those, and that's where I had first heard about it. But also micro COS I've run into, and free RTOS I run into a lot because I have been described as a STM32 evangelist because they're cheap and I like using them. And it's the one that's built into their ecosystem. If you download their stuff, there's a button to check to include free RTOS as well as ESP32s, I believe. So back in my days of playing with the ESP32 and the ESP8266, the development environment they had back then, which didn't include VS Code yet because it wasn't out, kind of had the option when you went through their configuration utility. So if you did the make menu config or whatever it was, it would, I think, give you the option to pull in free RTOS. And that's where my forward development chops for it kind of come from. But I don't think I've RE'd anything with free RTOS. I have done some VxWorks and some micro COS, and I don't like it. I prefer people just program bare metal and let me do that.
In C, preferably too. Please not C++. I have some.
Yes.
I have some battle damage.
I'll take that
from C++. But anyway, so we level in the playing field there. We've all experienced the drama and the pain points, and kind of popping the stack back a little bit to the earlier part of the question in that conversation. Like what does your workflow look like with it? We heard that you had mentioned, Ghidra. I think a lot of the challenge that I've experienced anyway, when it comes down to any embedded system in Ghidra, has been it doesn't have the automatic library identification support that a commodity operating system binary would have. So there's a whole lot of unresolved areas that it just doesn't know what to deal with. And that's not to talk about the situation which may occur too when you're pulling different types of memory into it, where you have Indianness issues with maybe flash, or you have to alias or associate different types of addresses away somewhere else inside of the program so that the Ghidra itself can like identify or automatically resolve references it was otherwise making to memory, which isn't there if you just kind of flatly upload it. What have you experienced that too? And kind of tell me a little bit about what your workflow or tooling looks like.
Yeah, 100%. In fact, I would say that was like the first problem I had to figure out for this project. It's just, what does the memory layout look like, right? It's, I know at some point this flash blob, although I did have to do some legwork to figure out where in flash I could even access this. And that was all based on the data sheet, figuring out how it sets up its internal memory map, which, by the way, there is no memory map for this particular processor. It's just like when you go to the memory map section of this processor manual. It's just like, here are all the memory mapped registers, but it doesn't say like, oh, SRAM should be here. This is reserved for flash space. So figuring out the layout of where your code's actually going to execute so that you can then set everything up correctly in Ghidra. I've noticed they've added a bunch of quality of life improvements over the years to Ghidra for changing your memory layout and even rebasing it. I think there was a point when I first started using it that there was no way to rebase an executable without re-importing it. Maybe I just didn't know, but now you can rebase it just based on just from the memory layout view. You still have to have an exclusive checkout, so that can be a pain when you're working with a geographically distributed team in remote time zones.
I could tell that could be a challenge.
But yeah, so figuring out your layout, figuring out, is Ghidra actually resolving these references or treating, this value as an immediate when it really should be treating it as a pointer. So there's a bunch of, capabilities built into Ghidra to do that manually, and if you can do it manually, you can script it. So if you figure out like, okay, Ghidra just is choking on this particular instruction, I start to look at, is there is there a script out there? Has someone run into this problem before? PowerPC is not a huge one that you see out there, maybe, but there's some scripts that are already in there. So yeah, figuring out. But then, I mean, with an RTOS, especially, you really need to understand at some level how the operating system is doing. Maybe not scheduling, but at least
Execution.
how is it actually handling, the memory layout of these files when each processes or task. I think at FreeRTOS they call them tasks. This one I'm looking at now, it's processes, because if you've got shared object files along with executables, like, you need to be able to understand. On the plus side, with this particular OS, I do have symbols for library calls, which is super
that's
helpful.
fantastic. Yeah. So at least you know what
Yeah.
library calls are being made. Gives you some
Yeah,
context for
of
what the
those that
function
were
is doing.
exported by the shared object. Yeah.
Ah.
So, yeah, I guess if you want to describe like a holistic workflow, it would be like, figure out how this thing's laid out in memory, get all the low-hanging fruit in terms of trying to find functions of interest based on what symbols you might have, and then the next lowest hanging fruit might be, do you have a function that you've identified that's clearly like logging an error message or logging any kind of debug string, and can you use that to inform for whatever particular function you found that in? And then from there, it's really, okay, what questions do I need to answer? Like, what's the overall goal of this reverse engineering project? What questions do I need to answer? What do I need to understand in order to answer those questions? And then you just sort of, go from there.
Yeah, I find that a particularly challenging thing to do sometimes. I think you alluded to it there. When do I stop looking? When have I answered, like, what's my desired outcome here? Am I just answering one particular question? Because if I am, I don't need to spend a lot of time on some of these other functions, which, are only maybe a handful of instructions. It's just doesn't make sense to. What are the in and outs of the main functions that I care about? And, it's especially nice if there's anything that's an example string or series of bytes that would be passed back and forth between it and something else.
Yeah, and I mean, a lot of times I personally have to go back to, like, what am I actually trying to figure out here? Again, to bring it back to this project. Initially, I had started thinking, okay, the question I need to answer is, how does virtual address translation work on this RTOS? And, the reason why I was trying to answer that question was so that I could find in-memory structures after they'd been initialized, so that I would know where to look to find those structures, right? And since my goal was to get those structures out of actual RAM, I didn't really need to know how virtual addressing worked. So instead, I changed my question to be, how can I figure out, knowing a virtual address, where the physical memory location of the thing I'm interested in is at? From there, it was a lot better because, one, I didn't have to reverse engineer their entire virtual address translation process, and I could just take advantage of the fact that there's an interrupt handler that will fire if there is a data load translation miss, and the output of that function is putting the most significant 20 bits of the real physical page number into the RPA register. So I hopped on the debugger, I forced the program counter to that interrupt, and I set the data miss value to the virtual address I was interested in, and figured out where it was in memory and dumped that. So now I've sort of short circuited that whole like massive
Skip the
question
rest.
of
Skip
like,
the static part.
yeah,
Excellent. Yeah.
yeah. So, but
Yeah.
I mean, it's things like that, like making sure you're not getting. Sometimes you need to like you have to go all the way down the rabbit hole to get an answer, or if like your job is to reconstruct an entire algorithm, like you're gonna have to go to the nth degree. But you know, in a lot of cases, right,
Depending on case.
get the information that yeah, it depends. Everything depends.
Yeah, I will share a quick story, just an embarrassing one. One of the very first like semi-complicated embedded RE projects that I popped onto, I spent an entire month reverse engineering this really archaic and weird looking function. I had no idea what it was doing, and I just kept getting wrapped around the axle on it. And long story short, I was taking for granted for the fact that the reverse engineering tool that I was using at the time did not resolve any kind of external libraries in the way that they would for like a desktop binary, and it was the sign function. So I spent, and I'm glad I found it at the end of the 30 days, because I would have went on to RE, all of the trigonometric functions. Thankfully, a
I was
colleague.
gonna say, I bet it only took you another day to get cosine, tangent, and the other ones.
Yes, it did. Yes, it did, and it was very nice. And I know it's hard to say what that feeling exactly is when you automatically resolve all of those, because you just went out and found the relevant developer libraries, and then you said, "Hey, Ghidra, these are what the functions look like," and they say, "Oh yeah, let me resolve all of these handful of other ones for you," and you're like, "Cool, cool, cool, cool. All right, all right." But any
It's the
event,
kind of thing that kind of only comes from experience, though, is that like, knowing what stuff you really need to know. It's like, hey, do I need to look into this and see what's really happening when they shift these bits by however many and AND them against this and do all of this other crap? Or can I just like kind of look at this whole block and say to myself, okay, yeah, we're just writing this out to somewhere, or based off what it's taken, this is probably some form of printf or whatever it happens to be. And just kind of and mark that and move on as something you don't need to do, or kind of get caught in the weeds, which I've definitely found myself doing, is trying to reverse engineer like every single line in assembly and try to understand all that it's doing, as opposed to just being like, okay, we're taking data, we're sending it to this thing, that thing's sending that data back, manipulated however else. I can see that this is, whatever this happens to be, and then just kind of move on and like look for the actual thing that you're looking for instead of trying to go through everything instruction by instruction, which I find myself doing a lot.
yeah, especially the start, it takes, I think, some time to know what shortcuts you can take. I mean, it only takes you probably it takes you, when you're like completely novice at it initially, a little bit of time to even just realize that a particular function call is being called a certain way and they're setting up the stack. So you might spend some time, trying to see what the function prototype for how to go to the next function, depending on whatever the language, both assembly and high level that it was compiled from is. But after you get it down, I mean, you realize, okay, I cannot pay attention to these first 6 assembly instructions because it's really just setting up the space for local variables. But you don't know that at the start, and just over time, it just takes time to build up all of those additional little insights, and then it seems to get reset. Because I don't know about you all, but I know that I'll oftentimes find myself in one kind of paradigm, like, hey, this is a Harvard architecture, and we're using x86, and then boom, fast forward 9 months, and now you're working on ARM. You know what I mean, with a separate data and instruction cache, or you come up across MIPS with the delays that are inherent in there, and you just have to experience all these things for from a brand new perspective for the first time. And that's a really long-winded diatribe on why I'm not looking forward to necessarily coming across anything RISC-V, which they say is going to be ubiquitous soon, TM, and spread over all the embedded world. Have any of you guys experienced RISC-V or played around with that yet?
Only from a forward dev side, not with the actual assembly, but programming for the ultra low power processor on one of the ESP32 chips.
So it's actually kind of interesting that you mentioned ARM in there because one, I like ARM has that really convenient instruction that just kind of like you can see stuffs a whole bunch of registers onto the stack. But there's something I ran into recently where it's kind of common in ARM to just save the link register onto the stack somewhere, and then just pop that back into the program counter. Like the first couple of times I saw that as like a function return mechanism, I was like, what in the hell is this half-assed bullshit? But it turns out that's kind of a common thing in ARM, especially if you're not like passing any arguments or anything to it. They just don't bother to go through the normal return sequence. They're just like, all right, well, it's just a pop straight to the program counter and then hop to the back to where you're going to. So it's kind of really frustrating coming from like an x86, x64 perspective to get used to that, seeing that in Ghidra and being like, why would you do this instead of doing it properly?
They're called conventions, Dell, not rules.
Listen, you're not wrong, but you knew what I meant. But also, it's like it's frustrating, right? It's like, listen, like, why are you just popping this straight off the stack into the program counter? Like, this isn't the way you're supposed to do it. But it's commonly accepted, you know.
I see that a lot in basically anything I've reverse engineered. It's you can sometimes tell, like, okay, this bootloader was clearly written in assembly, right? Because they just ignore all of those conventions, right?
Yeah.
You're branching to functions, and no registers were set up. They're all getting clobbered, and you're not even restoring the stack. So
kind of bringing that back around, I've seen that in a few RTOSs where they'll call like sub functions to do something. So like that main function that, you know, like hands out processing time and everything to certain threads or tasks or whatever it's called, will sometimes not do anything with any of the registers because it's like I already know where the registers are because this function has it. I'm going to send it over here to this function. It's going to modify them, but in a way that I know about, and then just hop back. And we're going to completely ignore any and all calling conventions and saving these registers. And it's just like we're going to use the registers as this weird global variable, like, and not worry about like protecting any of them or anything, and then just jump back by smashing a value back into the program counter.
That's a
my
good point.
gripe on weird ass free RTOSs or regular RTOSs, whatever.
Yeah, that reminds me too about some weirdness that I've seen when it comes down to is the scheduler and the tasks. Are they using mutexes and semaphores? How are they using them? And then that's kind of step one. And then the step two, right, is it doing that kind of multi-core setup type system? So I guess to ask you, Ryan, is the processor that you're using right now, is it just time slicing based over one processor? Or does it have multiple cores that you have to also contend with trying to wrap your mind around how that's working as you're REing?
fortunately, this is single core, thank God, because it's already difficult enough. But yeah, like that's one of the part I'm on now is trying to unravel how the kernel is doing that kind of management. So I'm trying to pull apart the kernel structure for what you could consider like a process information block,
Yep.
to figure out like basically when this thing does a context switch, it looks up some structure that it set up initially when it created the process, and then it will set a value into one of the segment registers, which is one of those registers dedicated to doing memory management in this processor. And just by setting that one value, you've completely changed the virtual address layout of whatever the next instruction is going to execute, right? So understanding how your kernel or your RTOS is doing not only scheduling, but if there is any virtual address translation going on, how it's setting that up is pretty key.
Yeah, I think that again we've kind of circled the wagon around it a little bit here all throughout, but each system that you come across is just going to be, even if it shares the same RTOS family, it's probably going to be bespoke. And it has to be, right? Because it depends on how the hardware was set up to be able to pull in any type of sensing that it's doing in the real world. Or, there's a foray that I've had to take sometimes into certain aspects of engineering that I'm not familiar with. Like let's say, for example, PID loops in general. You know what I mean? It's something that I come from the software kind of background, with a little bit of overlap in engineering there, but taken for granted for the fact that I didn't know initially what something like a PID loop was or what control theory was. So I think for me anyway, that's one of the big exciting points about doing RE on embedded systems, despite the fact that it's so challenging, is that it always kind of stays fresh, even though there are long stretches of it being a slog, because you always have to pick up something new. And each time you do pick up something new, I think it accelerates the time that you have to take through those slogs, typically speaking. And it just kind of is a fun optimization problem and beating your head against the wall kind of problem that I just find exciting.
I 100% agree. Like, I'd much rather learn about some new discipline and how it gets implemented in firmware rather than learning about the latest change to some Windows NT kernel structure.
Yeah, and for as diverse as electromechanical equipment is out there, if it's something that's coming from a power plant or if it's something coming from aerospace, there's going to be some new thing that you didn't pick up. And frankly, I think sometimes you may know at a deep level some of the concepts that exist for that domain that you may not otherwise realize about if you are only ever doing it from the forward development standpoint. Because it's easy to take for granted a lot of those other libraries that other people have written in a higher level language, but then how that actually gets implemented at the low level is always kind of a magical process to me. But yeah. So
Yeah, like sign.
Pivoting a little bit here to kind of like another question that I'm interested in hearing about from you. Is there any kind of projects that you'd like to share that's kind of been like some of the favorite ones that you've been a part of, or ones that you've seen from others that you think are really interesting?
I will say that my favorite ones, kind of like we were just talking about, my favorite ones all tend to have a flavor of sort of there's multidisciplinary aspects to the problem, to the challenge. It's typically a new architecture that I haven't looked at before. It's, I enjoy that initial getting started challenge of figuring out how am I going to connect to this thing? How am I going to dump memory from this thing that I've never seen before? And then just my favorite ones have been working with, people who have a lot more experience than I do in any of those aspects and just learning from them and figuring out how they figure things out. Pull a thread and then you start pulling more and more and you sort of open the aperture until like this whole new world is opened up to you and you can start answering the real questions.
Yeah,
So
those are great. I mean, they can also be disorienting too, from the standpoint of, since the most exciting parts are usually that kind of like initial foray that you have into it. And then also once you get to the answer to the question, sometimes there's a little bit of brain dumping that you do as you switch over to another project. But then 1 year, 2 years down the road, you're trying to think, oh man, how was it again that, what was the calling convention in ARM for doing, like this, based on this high level language, what was the calling convention to be able to do that? And I find that to be a little bit challenging from time to time, kind of finding the breadcrumbs back to the knowledge that I once knew deeply, although it was only probably for a few months, just to get that one.
so I will say working remotely, I have definitely had to deliberately develop the skill of documenting and brain dumping. Like to the point where now at the end of the day, if I don't write down everything that I had like figured out or put my notes into some sort of like legible context that can then be picked up by someone else, like work just gets lost, right? Because
Yeah,
I've been spoiled in the past by working in the same physical environment of all of the teams I've been working on where I can just, write something on a whiteboard or like say, hey dude, let me explain this how I think it works to you and see what you think. And if we both agree, it's just like, cool, now we all have that shared understanding that we needed.
right.
Would I need to write anything down for? You got it. I got it. Let's go.
Nice. Yeah, I can see that from like the remote aspect, not being able to just lean over and be like, "Hey, can I interrupt you for a second? I don't care about the answer that I'm going to interrupt you anyway. Here's a bunch of shit."
So honestly, for me, just not on that front, that same front is like when you've got a deliverable to somebody, right? Like at some point, your RE work has to go out to someone or some organization or some other organization within your organization and like at the end of the day, they need something, right? Like you have to have a product of some form to deliver to somebody, and I am the worst about writing stuff down. As I take terrible notes and I just kind of remember everything, hopefully. And then at the end of the day, when it comes time to give a product to someone, I don't have it, right? I got to sit down for like 3 weeks or a couple of months and just pound away at something and try to regurgitate everything that I learned along the way so that it's useful to somebody other than me just thinking it was neat in the lab. And like that's all I have to show for it is I found a thing that I thought was neat and nobody knows anything about it still.
Almost the opposite sometimes, depending on how ready to just ramrod it I am or not, where I'm tech VVV. And then there's a delicate balance in there somewhere where you have just enough to be able to like have those trace those breadcrumbs back, and too much to where it's just like Randall Monroe's comments on his Git commits where they're good at first, but then it's like hands, I'm committing. This is a commit, and then it becomes worse than useless. It becomes clutter. Like I feel it's in my gut that there is some sort of AI solution out there to be able to help out a little bit with like an auto documentation type of thing. I know that will forever be a challenge probably when it comes down to the embedded space, but for RE in general, it would be nice to have a co-pilot like it is right now for some of the other forward development things that exist.
I'm not sure I want Copilot to watch everything I do all day and then regurgitate a summary to me.
What would it look like?
But it would be useful. But I think that mental effort of like forcing yourself at the end of the day, like, okay, what did I figure out? How did I figure it out? And just like, even if it's, just in note form, basically, I think about documentation sometimes the way I think about a Slack post, right? Since I can't, verbally attack someone and point them at my monitor and show them what I figured out in Ghidra, I have to like step through that process in a way that will effectively communicate whatever I thought I figured out.
Right. Yeah. And that when it comes down to RE, I find that to be a huge challenge because there's a lot of mental leaps that you make in your mind. It's hard enough to communicate in general because we all sometimes come up with stories in our mind about like something that went on. And then when we talk to somebody about it, it's kind of like, how dare you not be on the inside of my internal thoughts, tracking the story as I, weaved it together off of, half true information. But yeah, when it comes down to technical documentation in particular, I find it to be challenging sometimes to how do you capture insight or intuition? Like I just felt that this was the right way to go. Or, hey man, I don't want to write this down on the report, but I was just making shit up until something stuck. And this is the thing that stuck, by luck.
Which, depending on your audience, may be an acceptable answer.
Yeah.
Right. When I put that in a report, I usually just write that through trial and effort, blah was found, or trial and
error.
Error. God, thank you. All right. Next week, I swear to God, I plan to learn to talk. But yeah, through trial and error, I found that this was X. Just leave it at that. I'm sure somebody knows that means I was just throwing shit at the wall and found something that stuck eventually.
So changing gears again here a little bit, are there any kind of security researchers out there that are, publicly available type folks or projects that you've seen at InfoSec conferences or anything like that have been inspirational to you or helpful to you along the way that you can recall?
Oh man, I'm sure there are hundreds of unattributed GitHub projects that I've pulled from at some point or another. I am so bad about keeping up with what's going on in the InfoSec space. In fact, and I stopped going to things like DEF CON. Like I haven't been to DEF CON since like DEF CON 22. The world has changed a little bit. But there's, obviously a lot of people and groups doing some really good stuff, and I owe so much to people who just put their code out there on GitHub and GitLab.
You and me both.
And
especially one who's really well documented. You're like, oh my God, what a hero.
Yeah.
It's so weird because I start so many projects with the plans like, oh, okay, when I'm done with this, I will commit this, and then the community, and then like I will have contributed and somebody can use my code for that, and then I never do. My GitHub is filled with projects that are basically just a framework and a first commit, and then I never committed anything after that.
Yeah, so I tried to do that once, and then the first time someone commented on something on a project that I hadn't touched for over a year, I'm like, okay, never again. Like, I'm not going to go back and try to fix something that I haven't touched, which is not a great answer, but that's why I don't actively communicate or participate as much as I
You
think
know,
I should or
actually,
would like to.
Dell will appreciate this. Years ago, I mean, years and years ago, at a DEF CON that we both went to, we were playing the DC Darknet game, and we assembled one of the badges from DC Darknet. And in it, we found that there was something called T, the tiny encryption algorithm. And so our plan was to brute force attack the tiny encryption algorithm with all of the possibilities over this little IR sensor. And so we set up the code to do that, and we were developing it. And I put that out there on GitHub just kind of idly. It wasn't quite all the way finished because by the time we did get to a point where it was at a proof of concept type stage, the competition and the con were already over. And it was like, oh, well, we tried. But I'd forgotten about that. And just 2 months ago, somebody in a comment to me on there said, like, hey, man, over here in this function, why didn't you initialize this variable? And I'm like, you see, there's no updates in here for like 8 or 9 years. Like, man, like I was just like, hey, man, like this was something we were putting together for a proof of concept, 8, 9 years ago on a weekend as a challenge. I don't plan on initializing that or going back. So similar experience, I guess, as you, but I guess for whoever
Yeah,
out
because
there was playing around with it.
there's this like mental pressure that if you're gonna put something out in the world, that it has to be complete, right, and polished to some level. When in reality, like my hard drive is just full of half-baked code snippets, and like even my largest projects, I would never want to see the light of day, right? But
Don't
they
look at my
deliver the
trash.
result that I'm looking for at the time. Yeah.
The other thing is like, man, people will be dicks about that shit. Like in particular, like it's you commit some half baked stuff. It's like, hey, this is a thing that I was kind of hacking on, getting working together, blah 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 blah. It is what it is, and then its current state, and then some dude like makes a comment like 7 or 10 or 12 years down the line, and they're pushing up their glasses like, oh, I don't know why you didn't just do this thing. It's like, listen, asshole, I was pretty clear that I was just kind of banging around on this, seeing what would work. Obviously, I'm not an expert in this particular area. There's no need to comment on my 12-year-old repository that I could have done this thing in like 5 instructions with whatever particular library. It's kind of an asshole move that
or
people
with a
will still
newer technology that didn't exist until well after you had done the commit. It's like, yeah, Rust
Right.
didn't exist back
That
then,
wasn't
man.
the feature of Python for 5 more revisions. That's why.
Yeah, it's like, yeah, I know that library is no longer available. I'll implement that too. Especially talking GNU radio.
Oh
Anyway,
my god. GNU radio changes are the worst because they seem to fundamentally change the framework every minor revision.
yeah, and then so higher blocks and stuff to share from Ryan's point, I love to go out there and steal stuff from people, especially for GNU radio on GitHub, GitLab, until I find out, oh, it's under version whatever, and I'm like, well, never mind. Probably won't re-implement that. But a quick scroll moment there myself on that. Probably will be thrown in other show notes since you and I had talked about it just a little bit ago. I think the last time that we spoke, there is a really cool GitHub out there from a couple of the different guys who were working back in the day on decoding LoRa. There's a great presentation that exists out there on the CCC, the Chaos Continental Congress website for decoding LoRa, the LoRa PHY. So LoRa, for those who are unfamiliar, is like a radio technology that's gained a lot of traction with mesh static and other people to be able to do kind of like comms without a cell phone tower. And some people are using them for drone projects and other stuff like that too. I don't know if there's a later LoRa project for the PHY, but there was a good anyway, I'll have it up there in the show notes, along with some of the stuff from Andrew Spice, a Swiss researcher who has all kinds of great videos, some of which I think were included in like a Homeland Security report on why the government should worry about LoRa radios. But anyway, I just wanted to say we were talking about that. And I know that in terms of personal projects that are going on right now, to segue into that, I know, Dell, you were working with LoRa. Ryan, what do you have any kind of side quests that you're working on right now outside of RE, maybe on a more forward front, or maybe even for an RE front?
God, I wish. I have a bunch of projects sitting on a shelf. Right now, I'm trying to reverse engineer a human.
Good luck.
Yeah, I mean the I/O starts out pretty simple, and then like all of a sudden
So
you don't know
the
what's going
IO
on.
starts simple with where you interact with it, but unfortunately, like every single indicator can mean one of 10 things.
Yeah. So I do have some robotic stuff that I really want to start taking a look at. That I found a Kickstarter a while ago called Robotics Access for Everyone, and they just have this little sort of toy robot that has a couple of cool sensors on it, optical sensors, and it's designed to sort of be an intro to machine vision processing and robotics. Still on the shelf. I can see it from where I'm sitting.
You got to have the ADHD piles. You know what I mean? Like it has to be in sight for it to ever see the light of day. Because once it gets
Yep.
put away, it's forever gone. At least that's been my experience.
There's a name for that. I
What's
think they call them doom boxes.
Doom boxes? Yeah,
The
yeah,
place where you put all those things that you're supposed to work on, and then eventually the latest thing you bought winds up being the thing that's within line of sight. So that's what you do.
Yeah, I've tried to make sure like all of my storage containers are clear, so at least if I put it in a box, there's a slightly greater than zero chance it may come back out.
yeah. I think that here for the show and maybe for something else to maybe do at some of those InfoSec conferences, I had mentioned programming the STM32 that I'm messing with right now. I do have a 401 RE, and I also have a 407 VG, which has some analog to digital conversion as well. The big thing that I had mentioned I wanted to do there, at least for high speed anyway, USB, was to be able to get to the point where I could have that over the GPIO, because I ultimately would like to work on a project to create my own SDR. The very first thing that I thought of with that was how am I going to interface with the computer, and that started me down a rabbit hole. And all my Doom piles right now have STM32 microcontrollers kicking all over the place. I think it would be cool along the way too to do kind of a make it break it type of video series or something like that. Maybe we could talk about on the show for developing it from the forward part and then pulling out the binary and taking a look at it inside a Ghidra or something like that to talk about some of the things that you'll run into, which we've talked about here on the show, like trying to see if you can get in the STM32's cases the SIMSYS header files down and or libraries to be able to identify if your binary that you're looking at came from an STM32 and things like that. So that was just kind of a personal project that I've been
So
messing around with right now.
one interesting note on that, one of the newer guys at work kind of turned me on to something for Ghidra. There is an add-on that's specifically great for STM32 chips. You can go. There's a GitHub repo out there that I can't remember where is, but I can go find so that I can give you for the show notes, I guess. That has a ton of SVDs for different chips, and then there's a Ghidra SVD loader plugin where you can basically just go grab the SVD for your chip, throw it through this plugin, and it will build the whole memory map for your entire chip for you in like maybe 30 seconds of work instead of the like typical 3 hours that you spend going from a datasheet back and forth
Wow.
for all the different memory mappings for where everything's at.
Yeah, that's super cool. On the RE front, with helps with regards to work related things, there was a couple projects that I was tracking to be able to help resolve some of the C++ like functions, the function names to where you didn't have to manually go out and map like all of them for the lookup table. Played around with that quite a bit, but RE on the RE front, things have been taking a backseat, unfortunately, a little bit here, just due to a shift to some work related stuff over to a little bit more like on the forward dev. So popping back into the conversation here though, Ryan, we talked a little bit about the software tooling. Are there any types of hardware tools that you really like? Like, let's say, for example, ones that you like to use to pull off. What are some of the, hardware that you use and that you like to be able to do things like pull flash memory and things like that from boards that you're pulling binaries down from?
I guess it all depends on where the binary resides. So I've used, like Bus Pirate to get things off Spy Flash. More often than not, I find myself pulling Flash directly from a processor using like OpenOCD and a debugger, or, in the case of this latest project, a Code Warrior USB tap, because the flash itself was actually a 64-pin BGA, and there's no way I was getting that off the board. I don't currently have access to a universal programmer. I miss having that because I do have a couple of NAND flash chips that a smaller pitch than I personally can work with to pull it off. If you're already looking at a universal programmer, like one, those things are ridiculously expensive to begin with, but then each socket, each ZIF socket that you're talking
Well, the
about
good ones
is
are.
like a couple $100.
Yeah.
Yeah.
If you want to go the cheap route, what is this thing called? TL866 in one of those variants. I don't use the software that it comes with because it's Chinese. So, like, if you do, I recommend you do it in a VM. I don't even like plugging their firmware into my computer, so I've got custom firmware on it as well from some guy on GitHub. But there are some options that direction as well that come with like TSOP 48 as well as maybe even some BGA possibilities.
Oh yeah, there are. If you can, there's a good chance that if you look at it on Amazon too, you'll be able to find some kit that has a lot of different types of connectors. So connectors that are like ZIF to whatever the form factor of the flash is. And if you can't find it in one of the bigger kits or something like that, there's a good chance that you can find a one-off of that particular ZIF to whatever the particular flash it is that you have. There's also some pretty cool stuff that we shared in the show notes from the past about people being able to get those off with a custom sketch from an Arduino if you wanted to be able to. It's obviously going to take a super long time to do, but I think it might have
There
been.
you go. There's the right one.
Yeah, I think if we looked in, it might have been the episode that we talked about Flash on. If you look in the show notes for that, there are some good ones to take a look at. Good different options there for the cheap home gamer type stuff. Yeah, Radio Man V.
The other thing I
That's the
build.
firmware I have. There is also, it is called, the software for interacting with it is called something different. It's just called MiniPro for Linux or something like that. And that's the software I use on Linux to build it. I don't know if he goes over that in his thing, but there is the firmware, which I think is what you just linked, and then there's the MiniPro software that's available for actually pulling it, the client side stuff that you would run. And that way you can avoid using the Chinese software that comes with that sketchy device. But so there, as well as on eBay. So that's where I found my TSOP stuff when I wanted to upgrade to doing TSOPs for some stuff for work. There's a lot of like available crap basically on eBay where you can, just go grab the thing and then toss a chip of whatever particular type in with it.
Yeah, if you want, as you well know though, if you want a nice one, it's going to be probably a few grand.
Yeah, so I know some of the nicer ones from work, and man, are they expensive.
And I don't have, more than moderately competent with a soldering iron to get chips off boards. That's definitely a skill I need to
Will your
improve.
company pay you to go to like the micro soldering class that iPad Rehab offers?
Probably not, just because we don't
No, that's a
have. Yeah, I mean they might. It's just the level of work we've got right now. I'm like the only reverse engineer who's actually able to come on site currently. So me being away for a while might be problematic. But also, like, we have technicians, but they're all for the forward development side of the house. So I have been able to ask them to pull stuff off boards for me before, since they're supposed to be building stuff and I'm supposed to be breaking stuff. I'm not supposed to be asking them what to do.
Is there any other types of things on your tool bench, so to speak, that you really like and enjoy and think others would benefit from knowing about?
Definitely Salia, the logic analyzers, although those are really pricey now. Like I think
They
when
are.
I got my Logic 8, it was like $200 or $300. Now they're like what, like 700?
Yeah.
But just being able to, maybe not necessarily for dumping flash, because it can be kind of a pain to get big chunks of data out of it, but just understanding digital logic, incredibly useful.
Yeah, to the point
But I
of
think there are
dynamic.
some more low budget.
I will say that something that I have had a lot of really good luck with lately, not necessarily for like big like BGA style flash stuff, is that there are a lot of projects available for the FT232H in its various forms, be it via cable or a board or something.
Oh yeah.
For bit banging flash off of I2C, SPI, hell, even JTagging with it, and then just dumping via what is that software you just mentioned that I'm totally spacing on now for doing JTAG? OpenOCD, thank you. You know what I mean? And there being so many processor modules and the ability to make them out there, like it is crazy how much you can get done with one of those cables or one of those, chips on a board somewhere.
Or, I mean, really, I've started to just kind of like follow some folks who have been doing a lot of different work, especially like Colin O'Flynn, who created the Chip Whisperer, and some of the groups over on Mastodon who migrated over there, post Twitter changeover, have really started to do a lot of different like custom tooling with FPGAs, but also sharing out what those are. Because obviously those are great for, if you're trying to do anything sub nanosecond, you start to get into custom hardware and you're usually thinking either actual custom hardware or FPGAs. And so if you're wanting to be able to just create a file really quickly, I'm sorry, a bit file really quickly, there are some other software tool chains that have come out. I think Yosis and the related projects to be able to quickly throw those things together without having to go through all of the pain of proprietary tooling from whoever it is. What name your FPGA company, their tooling is probably not great. That could be some good MacGyver kit probably to have in your tool bag too. So let's say there is somebody new who's getting into the game. What kind of device do you think you have for somebody who is kicking into reverse engineering from the first time? What kinds of backgrounds or schooling or education or attitude do you think would be helpful?
I think a general background in computer science and computer architecture. I mean, it depends if I'm someone is interested in more of the software side of the house or the embedded side of the house. But I think a computer architecture class is definitely a must for both of those applications. And then just reading what's out. Like there's so many resources now, like MIT, like OpenCourseWare, master's level education for free if you have enough time and patience to sit through some of that stuff. The downside though is obviously you don't have the forum to ask questions, but if you can find, a friend or a mentor, someone who's willing to let you ask the dumb questions and be willing to learn and suck at something for a while is a huge resource that I don't think I would have gotten to where I am without having. And then I guess just general advice is, don't don't give up. There's always going to be times when it sucks and when it's hard and things don't make sense, and then you're going to have, other times where you feel like, the king of the world because you figured out how this really seemingly esoteric thing functions. So there's a lot of highs and lows in this game. One thing I would point someone to, and maybe I should have mentioned this earlier when you were asking about projects, the micro corruption website teach a class from like the fundamentals of reverse engineering and exploitation and exploit development to some of those challenges get pretty sophisticated. If you haven't seen it before, I guess it's put out by the NCC group.
Yep.
And it's just a web-based embedded or set of embedded reverse engineering challenges. I say embedded just because it's using an MSP 430, but it's the challenges are all set up to unlock doors, and you go from find the password in memory and submit it for your answer to I don't think I've gone past level 10 or the 10th level where it's like slightly more complicated than just a stack-based overflow. Like there's a little bit of ROP in there, a little bit of shellcode writing, but just the ability to get really deep into a debugging environment without having to figure out how to set everything up, because it can be really easy to get discouraged in just the getting started portion of a project or trying to sit down and learn a new concept or trying to understand how a stack works, where it's really valuable, at least for me, to actually step through a processor as a processor's executing and see the things that are changing in the register, see the things that are changing on the stack, and it can really help cement a lot of those concepts that are abstract when you're learning about them from a textbook, but in reality, like they're very concrete because that's what's actually happening on a processor. Is a resource I wish I had access to, and it was something I would definitely point someone to who's just sort of starting out in the reverse engineering world.
Yeah, definitely echo those comments. I think that years ago, when I was similarly kicking around and getting into some trouble, as were you, just microcontroller game themselves. There was mostly one player in town that I recall that was AVR, and it didn't have a lot of the great tooling. A lot of the other, microcontrollers and other things like that exist, and the support around them, like whether that be Lady Ada and her blog, who I think she really paved the way or the maker movement out of NYC and in Washington. And a lot of the InfoSec conferences, there was mostly just, if you weren't, in engineering academics or employed in the space of engineering, you probably weren't going to be coming across it unless you happened to be part of an area that had a group that had meetups, like the classic, what was the one that existed up there in New York, Cult of the Dead Cow, I think. And some of those other early groups,
Yep.
you probably weren't going to be picking it up. You certainly didn't have anybody else to talk about it with. So I do think that there is so much out there now, and you just got to start. You got to start in one of those directions, talk to people along the way, and then just see what resonates with you. I'll also say that you're right. It is discouraging for a long time when you're beating your head against it, but there's always a moment, not always, but when there is a moment that you do beat it and you just feel like the just smartest person in the universe, I think a lot of your subsequent, things that you get into are kind of maybe chasing that feeling again. I'm not going to let this processor beat me. I'm going to beat this one. And, when you do have those exciting moments where you're throwing your hands up because it worked and you figured it all out and unlocked the secrets is something that you're absolutely never going to experience if you don't start and sucking at something is the first step of getting sort of good at something.
So I think that thing that you both just described is something that was a big hurdle for me as I was kind of getting into stuff, because you watch videos, you read blogs, stuff like that, and what they don't go over, what they skip over completely, is the hours in between each step, right? Like some of those slides may have had days worth of 8 or 10 or 12-hour days of fucking it up over and over again that you don't see, right? They leave out because nobody wants to hear about that at DEF CON or whatever black hat, whatever thing you happen to be going to or whatever blog you're reading. You miss all of that just god awful trench work that sometimes has to get done in order for you to get to that next dopamine hit, basically, and like the subsequent like small wins that you'll get along the way. And that was, for me, I was like, man, do I suck at this? Everybody else seems to be doing this practically instantly. No, they're not. You just don't get to see that crap, right?
Yeah.
It's not fun for a presentation.
Yeah, try to run your own race. It's hard to compare because there are some people out there who just benefited, I think, probably from, they have some compound interest from being in the right place at the right time as a younger person. The kind of gilded path that goes on from there sometimes, allows somebody to get somewhere a little bit further, but you just got to kind of run your own race and focus on what you can. Right. So, Ryan, is there anything else that you'd like to leave out there for the people, our listeners, or anybody else? Any parting shots, parting thoughts?
Both of them.
No, not really. I'm glad you guys are back at it, doing it again.
Us too. I think that we, at some point here, we're going to get you some swag or something. We haven't come up with the actual prize for whoever won the challenge, and we'll probably have another one here coming out sometime soon. TM, right?
I did not know that was a challenge. I was just like, what did these jokers put at the end of this episode? I'm going to figure this one out.
Oh, I don't even remember what it was. I forgot completely that we did it. And a screenshot of the message on whatever it was. I was like, oh, fuck, we did put something. I didn't even remember what the challenge was. I think it was Morse code.
It was Morse
It
code.
wasn't
I had to
just
go back
Morse
and listen.
code.
But actually, it has, if you take that string too and you throw it onto our website at the end, it takes you to a splash page where it says, hey, shoot an email over to either one of these email addresses with the title, Tuck Your Chains In. I think we'll pass over some information to you or give you a shout out on the show or something like that. But super, super thrilled that you were able to catch that. I was curious if anybody would, but super excited that not only you got it, but then it led to this conversation too, because it was a pleasure to have you on the show. Loved hearing the insights that you shared. All right. Well, thanks for showing up today, Ryan, and we'll see you all next time.
repp.show. Nerd Talk IO.